Good morning. My name is Christian Williams.
And I'm Lucas Molander.
And this morning we'd like to talk to you about the use of electroencephalographic technology for autonomous control of a Board of Education robot.
Do what's called a fast Fourier transform on the data, because the raw data itself isn't actually very useful. It's very noisy because of all the signals running through the air, and if you move your head a little bit, it would get really spiky. So this is an example of what a fast Fourier transform graph might look like. We had one neutral thought at the beginning. We thought that was good enough for a while, but then we realized that the data was highly variable, so we switched to two different neutral thoughts. And we had first a neutral thought, then some other thought, and then another neutral thought. And then we took the difference between those two neutral thoughts, and we used that to compare the other data against. We used proportions. What we did was we took the difference between the two neutral thoughts, and then we had that on the denominator, and then we had the difference between the first neutral and whatever thought that was going on at that time on the numerator. And for example, channels 3 and 4 for trial 1 on Fords are about 1. That means that there's almost no difference between the neutral thought and the Ford thought. And for example, in channel 1, all those values are pretty high, so channel 1 might be a really good channel to look at for looking at differences, because they're all really relatively high compared to the difference in the two neutral thoughts. What we did was we used this to set some threshold, like for example 1.3. I mean, if there's at least a 30% difference between the neutral thought difference and the neutral and different thought difference, then we would set that threshold there. And if it were higher, it might mean forward. If it were lower, it might be backward. If it's in a specific range, it might be neutral. Our headset wasn't bad. I mean, it was pretty good, but if we could, we would like to get our hands on a headset that's maybe $20,000 or $30,000 just for really, really accurate readings. And also, like Christian said, the readings between different people might be different. And so we would like to get lots and lots of people and find out what's consistent throughout the entire population, so that we can just put it on somebody and let it go, rather than having to find different thresholds for each person.
I was wondering, when you think about Ford, are you thinking like the word Ford, or are you thinking about a robot, like visualizing a robot moving, or is there anything related to the training of what your thoughts should be?
It's like visualizing it moving forward. Like we had it on the ground, and when he was thinking forward, he would think of it actually moving forward. So a really large problem we had was it took a long time to actually get the data and then analyze it. So we just wanted to be able to go, get the data, analyze it, which is what we did.
All right, let's thank you.
Yeah.